Okay, I was umming and ahhing whether what we should do first, but let's just start nice and easy. Oh, excuse me, frog in my throat. Okay, so the first question here is from the September 2023 papers. So basically last year's trial exams. People say the trial exams are a bit harder than the finals. I mean, you can look at papers to decide that. I don't think so, but I mean, also my opinion will be very different to someone else's. So always good to look at a trial paper. Alrighty, so in geometry, the first and most important thing is that you read the question. Read your question carefully, make sure you know all of the information that pertains to this question, then you can move on to whatever it is you need to work with. So here we have been told in the diagram below, PR is the diameter of circle PQRS with center O. PR intersects with chord QS at T such that angle PTS is equal to 90 and angle PRS is equal to 33. Now, what I find really helpful is to draw my diagrams. You are welcome to do that. And even more specifically, I like to identify my Dr. CPT. If you have no idea what I'm talking about, that's fine. So Dr. CPT, I don't know why I've spaced that so much, but anywho, is just a little reminder of things to look out for that are really important that then revolve around geometry reasons that we use. So D is diameter, R is radius, C is cyclic quad. So remember, cyclic quad is where all four vertices are on the circumference. P is parallel lines, T is tangent. So look out for these things on your diagram as well as in the information of your question, because all of these things are going to be really useful for you because these are the essentially the geometric reasons that we use when we're now starting to solve for unknowns. So Dr. CPT, really useful little reminder of things to look out for. So what I like to do is, based on Dr. CPT, I either like to then go highlight any of those things that I see. So remember, we were told that PR is diameter. I hate everything about what I'm trying to do here. So let me reattempt this. So PR is the diameter. Now I'm going to highlight that for myself because remember, diameters subtend angles of 90 on the circumference, angles in a semicircle. So I've got a diameter. Obviously, any line now drawn from the center to the circumference is a radius. So for example, OP is a radius and OR is a radius. If I were to join, let's say, OS or OQ, those would also be radii. So that's the first thing I was told. The second thing I was told is that O is the center. In this case, it's not super important because I don't have any angles around there, but I've been told O is the center. And then I've been given the 90 degrees at PTS as well as the 30 degrees at PRS. So that's all of the information I've been given. In terms of Dr. CPT, I can also see that PSRQ is a cyclic quad. Sorry, I don't know why the lines are squiggly, but that is a cyclic quad because all four vertices are on the circumference. I don't have any tangents, no parallel lines. So that's sort of what I have right now. I haven't even looked at a question yet. I've just broken down the information that I have so that I can now go answer my questions. So the first question I've been asked is determine with reasons the size of, and the first one is angle P1. So P1 is up there where I put the dot. So I want you guys to take a minute or two, think about how you could potentially get the size of angle P1, and then you can either unmute yourself, put in the chat, but how do we get the size of angle P1? I'll give you a hint. You can't get directly to P1. You're going to have to do some other steps first before you can get to P1.
Ma'am? Ma'am? Ma'am, I can't hear you.
Because I'm on mute. What's up?
Okay, ma'am, for us to get P1, right? I used angle Q1 because lines in the angles in the same segment with R, right? And then
Nice.
line from center, which is OP, bisects the chord QS, which makes angle T 90 degrees. And then we're going to add 90 plus 33 to get angle P1.
Nice. Okay, amazing. Guys, that's exactly it. That is exactly it. So I also just want to go back to something quickly. You said that the line from center bisects QS. That's going to be really important just now. So just, somewhere in the back of your head. I do apologize. I was on mute. I got excited. Forgot to unmute myself. Maths is exciting. I made a joke with my grade 9s today, and no one found it funny. It was a math joke. And now I have to tell you the math joke. So I don't know how many of you learned your parallel lines like this, but I do it as fun because they can remember it. And so I said, don't worry, guys, this is going to be fun. No one caught on to me. Felt very stupid. But anyways, right, let's do this. So first things first is those angles in the same seg. So remember, you're looking for like a butterfly bow tie shape. Angle R, thank you, Kirsten. I appreciate you. Thank you. Thank you. Thank you. Angle R and angle Q1 are angles in the same seg. So exactly, we can now say that Q1 is equal to 33 degrees. And remember, grade 12s, you write down everything. If you are not sure whether or not it should be written down as part of your working out, write it down. So this is 33 degrees, angles in same seg. We were then obviously told that angle PTQ is equal to 90. Now, there's a couple different reasons that you can give here. You could give angles on a straight line. You could say given, I wouldn't say line from center bisects chord because you don't yet know it bisects the chord. We're going to use that in a second. But I mean, it is 90. If you really feel that way, angles on straight line. And because of all of that, and because we now have two of the three angles in the triangle PTQ, we can use sum of angles in a triangle. And so therefore, angle P1 would be equal to 180 minus 90 minus 33, which is 57. Right now, as you start to work out things, Kirsten, I do see a hand, I'll get you in a second. As you start to work out things, I would write it down. So now I know this is 33. I know this is 57. It just means that you've got more and more information to work with. Kirsten?
Hi, ma'am. I did it a bit differently. I just wanted to know if this was probably okay. So since angles are on a straight line, so at the bottom of T, we can continue the 90 degrees. So I got S2 by doing sum of angles in a triangle. And then I said that S2 and P1 could be equal because of the bow tie.
Absolutely. Perfect. Yeah, I didn't even see that. So you could absolutely, English. You can absolutely use angles in same segment with S2 and P1. Perfect.
Okay, thank you, ma'am.
Sure. This is why geometry is fun, guys, because there's so many different ways you can do these things and all of them are correct. Woohoo! Okay, so the next one that we want is angle Q2. So Q2 is this bad boy over here, the blue dot. Let's take a second, let's think about it. How are we going to get angle Q2? Now remember, you're starting to work things out, which is why I'm saying put it on your diagram, because now you've got some angles that are going to help you. Also remember to go back to the information you were given, the fact that PR is a diameter. Right, Ati, I definitely agree with you. Do you want to unmute yourself and explain it or give a reason? Ilova, nice. If I pronounce your names wrong, guys, please correct me. Like that's for me to learn, so just let me know. Lovely, lovely, and I'm glad. I'm glad that there's a reason there as well. I can follow that. Awesome. Okay, nice, guys. Okay, so remember PR is a diameter, which means that the angle at the circumference it subtends is 90 degrees. So what that means is that angle PQR is equal to 90 angles in semicircle. And then, because you've already got 33 degrees of that 90, you can just say 90 minus 33 in order to get Q2. So Q2 is equal to 57 degrees. You don't really need a reason. If you feel strong, you could say complementary angles, which add up to 90 degrees. You could, it's not really necessary. Comp angles is not really a reason we use a lot. You can use it, you don't have to, completely and entirely up to you. Okay. Cool, so we've got P1 and we've got Q2. 8.2 then says to us, if QS is equal to 16 and PR is equal to 20, determine with reasons the length of OT. So again, I'm going to fill in what information I've now been given. So QS, which is this chord, is 16 centimeters. PR, which is the diameter, is 20 centimeters. We are looking for the length of OT. So OT is this green little segment that I'm highlighting over here. Not very well, clearly, but that's the length I want. Now again, look at what you have. OT is a random little line segment on one of the radii or on the diameter. What on earth must I do with that? Whenever you're talking about lengths, my advice is to look out for things like right angle triangles, particularly with circle geometry, particularly also when you have a line from your center at a right angle to a chord, which is what we have here. And this is what we said earlier. Because this line from center, get a color here. So because this line, OP, is from the center, and because it meets with this chord QS at 90 degrees, we know that TS is equal to QT. It bisects the chord. And so we actually know that this is 8 centimeters. That's a weird looking 8. Let's get rid of that. Why do you hate me? Okay, we know that this is 8 centimeters and this is 8 centimeters because the whole line was 16. It's bisected, so 8 and 8. And then obviously remember, because PR is a diameter, the radius from O to R is 10 centimeters, and from O to P, 10 centimeters. So sort of getting there. If we kind of have a look now, we have OT that we want, we have the length QT. And remember I said to you earlier, if you were to join O and Q, you would have a diameter. It's a terrible line. Let's try that again. You would have a diameter. You wouldn't have a diameter, you'd have a radius. And because we've just established that the radius is 10 centimeters, what we have now actually got is a right angle triangle. QTO is our right angle triangle. And so we can use Pythagoras here in order to get the length of OT. So whenever you have a length, and particularly when you've got a line from your center perpendicular to your chord, or even if you're told it bisects your chord, you have a right angle triangle. And so you can go and use Pythagoras. So I'm going to give you guys like 3 minutes. I want you, based on what we've just discussed, based on what I've said, I want you to go and work out the length of OT. Right, when you do get to answer, you shouldn't be getting any surds or anything. It's a nice whole number. So if you get a weird looking answer, just double check yourself. Okay, I'm sort of just waiting for an answer or two on the chat and then we'll go through. Nice, grade 12s. Okay, let's have a look. So the thing to be careful with here is you already have the hypotenuse. So remember your hypotenuse is, I'm sorry if you can hear my chair squeaking. I didn't realize how much it squeaks until today. We know that the longest side is always opposite the right angle. So OQ is the longest side. So Pythagoras says hypotenuse squared is equal to the sum of the square of your two other sides. That is your theorem of Pythagoras. And so in order for us to now go and solve for OT, we need to use that. Now, OT is one of these sides. So it would have to be hypotenuse squared minus, I don't know what I'm doing. It would have to be the hypotenuse squared, so OQ squared minus QT squared, which would give us OT squared. And remember your reason Pythag. So this is going to be 10 squared, which is 100, minus 8 squared, which is 64, will give us OT squared. 100 minus 64 is 36. So OT is equal to 36. No, it's not. It's equal to the square root of 36, which is 6 centimeters. I know it's centimeters because in this question, it told me that my units I was working in is centimeters. The units is not a major thing. I'm quite pedantic about units, but I've also learned to let it go. But it does have units. Any length has a unit, so just bear that in mind. Right, nice. Okay, let's take a screenshot of this and then let's have a look at the next question. Right, question 9 from the same paper. So still the mock paper from last year. Says, in the diagram below, O is the center of the circle and KP is a tangent to the circle. Ln, the diameter of the circle, is extended to meet KP at P. Straight lines OK, OM, KM, and KN are drawn. So just letting us know that those are actually straight lines I'm working with, not weird, non-straight, non-linear lines. So again, go through your Dr. CBT, figure out what information you have and what you can use. First thing is that I know O is my center and that Ln is my diameter. Cool, apparently we're not going to do that for me. Okay, you know what I'm trying to do. Ln is the diameter. I wish I understood. There we go. The next thing that we were told is that KP is a tangent. So this line up here is a tangent to my circle. And so the second I'm told things like it's a tangent, it's a diameter, it's X, it's Y, we can start to apply the theorem. So your tangent theorems, think about tan perpendicular to radius. Think about tan chord theorem. Diameter, think about any radii. Think about angles in semicircle. Those are all bits of information that we have. Okay, we do have a few radii here that we could highlight for ourselves if we wanted to. So one of those radii are OK, as well as OM. We don't have a cyclic quad. Technically, we do. We've got LK and M. M and N just aren't joined. So we can use that if we wanted to. But that's sort of where we're at. So the first question is asking us to write down two angles equal to 90. Now it says without reasons, but I want us to give reasons because obviously we should always be giving reasons in geometry. So take a second, have a think. I want two angles that are 90 degrees in size. Nice, Emmanuel. Very good. Okay, so Emmanuel's got one. I'll write it all down in a second. Let's try to get the second one. Okay, let's have a look. Hopefully the second one will become clear in a second. So Emmanuel has very correctly said that angle OKP, golly, no, okay, I'll just go here. OKP is equal to, nice, guys, I don't know what's happening. Okay, let's try again. OKP is equal to 90 because of tan, perp, rad. I'm going to be honest, this is the one that I struggled most to see. So Emmanuel, well done for seeing it so quickly. So this angle here, so K2, 3, and 4, that is equal to 90 degrees. The other one over here is LKN. Let me just get my letters right. LKN is also equal to 90 exactly because of angles in semicircle. Now these two do overlap. So when you are like putting this on your diagram, don't panic. LKN is in angles K1, 2, and 3. So there is an overlap with the right angles, which is fine. It's not the end of the world. Just bear it in mind. Perfect. So now we've got two 90-degree angles and we can move on. The next question says if K4 is equal to X, so this angle up here is equal to X, write down the following in terms of X, sorry guys, giving reasons. All right, so the first one is angle L1. So this one over here with a circle. What is L1 in terms of X? Have a think. Let me know what you think. You can unmute yourself if you want. You can just put it in the chat. K4 is equal to X. What is L1 in terms of X? Nice, RT. Okay, exactly. L1 is tan chord. Your chord is Kn, tangent Kp in the segment L1 is equal to X. So angle L1, excuse me, is equal to X because of tan chord theorem. Again, guys, as you start to work these things out, put it on your diagram for yourself so that you know what you're working with. I'm just going to throw a little tantrum here about my technology. That's equal to X. Okay, the next one is angle K1. So that's the one up here that I've drawn a little star next to. So have a think, have a look. What is angle K1 in terms of X? Okay, Bongi and Kosi, can you explain why you are 100% correct? Can you tell me or can you explain why you've got equal sides? What makes them equal? Can anyone tell me why we can use angles opposite equal sides here? Nice, okay. Yeah? Bongi and Kosi, do you want to let me know? I heard you. Did you unmute? I think it was you. Always like to hear your voices. Okay, no problem. All right, so if we have a look, remember I said look out for radii. OL and OK are radii. So because they're equal, we've got angles opposite equal sides. So OK is equal to OL, radii. And so therefore, K1 is equal to X angles opposite equal sides. Excellent, grade 12, well done. Okay, so now I know this is also equal to X. The next one that I want is angle P. So angle P, remember, is this sad little sausage all the way out here. Maybe let's not use that. Let's just do that. So that angle P, what is the size of angle P? This is a little harder, so I'll give you a minute or two to think about it. And again, feel free to unmute if you want to explain, ask a question, or put it in the chat. But let's see what we get. I'll give you a hint. You need to look in a triangle. Sum of angles in a triangle might be useful to you. Are we struggling with this one, grade 12s? Has anyone got any ideas? I don't even need an answer, just an idea.
Ma'am,
Mm.
I'm not sure, but then can you say that angle O1 is 90 degrees because of the two tangents coming from the same point having equal angles?
Okay, so which two tangents are you talking about?
Ma'am, LP and then KP.
Okay, so just be careful. LP isn't a tangent to the circle because it's going straight through the circle. I like what you're thinking though. So I like the fact that you're going to this 90 degrees. And if we go and have a look at this big triangle, oh, gracious golly. Okay, maybe I mustn't get so excited. At the big triangle LKP, so the big one. As you've just said, we know that we've got an angle 90 up here. And if you look at the whole angle K, it would be the 90 of K1, 2, and 3 plus the X of K4. So this is 90 plus X. You've got angle K. We know that angle L1 is X because we proved it. So we could just use angles in a triangle to go and figure out what angle P is. So I'm just going to write this down. Angle K is equal to 90 plus X. We obviously don't need a reason for that. It just is. And so therefore angle P would be equal to 180 minus 90 plus X plus the other X at angle L1. And this is all because of sum of angles in triangle. (180 minus 90 is 90. X plus X is 2X, so minus 2X. So angle P is, oh, gracious golly, 90 minus 2X. So I like the idea of working with the angles we already have and trying to get to a point where we can figure that out. All right, so I'm just going to move this because I don't know why I put it so far away. So angle P is equal to 90 minus 2X. So question 9.3 is saying to us, join MP. So join the points M and P, which I'm going to do here in this yellow. Not a very straight line, but whatever. And it's saying which is a tangent to a circle. So this MP is also a tangent. And hence prove that KOMP is a cyclic quad. So KOMP is that which I'm highlighting in yellow here. We want to prove that thing as a cyclic quad. Now, it's not in the circle we have. So we almost need to imagine, can I draw a circle through K, P, M, and O on the circumference? Now, remember, there's 3 ways to prove a cyclic quad. Number 1 is you need to prove that your opposite angles in your cyclic quad are supplementary, so add up to 180. Number 2 is you need to go and see if the exterior angle is equal to an opposite interior angle. And number 3, you need to see if angles in the same segment are equal. Now, you need to look carefully at what you have, okay? We could potentially use angles in the same segment. I definitely have no exterior angles. And if we look at this quad that we've drawn, I know that one of the opposite angles here is 90. I don't have a complete opposite angle anywhere else, but I do know one of them is 90. I've also been told, and remember, I don't give you any useless information, that this MP is a tangent. So I want you to, again, take a minute, take a second, have a think. How are we going to prove that this is a cyclic quad? Okay, let's see what we've got. Okay, so Bongi Nkosi, OMP is equal to 90. Love it. Tan per Brad, I'm in full agreement. So this angle here is also equal to 90. Wonderful. Emmanuel, angle K and angle M. Okay, awesome. Same thing. Perfect, guys. Well done. Okay, so exactly that. And again, I told you that MP was a tangent. So clearly it's important. So we know that angle OMP, so this angle down here, is 90 degrees because tan perp rad. And then look, you've got a 90 here, you've got a 90 here, 90 plus 90 is 180. So we know that OMP plus angle OKP is equal to 180 degrees. And so because of that, we've proven that KOMP is a cyclic quad. Cyclic quad. Now there's two reasons you can give here. Sorry, that's a weird looking quad. You can either say opposite angles supplementary, so add up to 180, or you can say converse op angles of cyclic quad. Either one is fine. Personally, I use a converse reason. That's the one I remember. Either one is fine though. It's completely up to you. It's also dependent on what you've learned. But like I say, both of them are fine. Both of them will get you the marks. But remember, when proving a cyclic quad, there's three ways to do it. You need to look at your diagram and decide which is the most appropriate given the information that you have and what you were given in the question. Okay, so cyclic quads, I want to say how tricky they aren't, but you just have to look very carefully at what you actually have and how you can go and use it to prove what you need to prove. Okay, would you guys like me to take all my scribbles off of the diagram so that you can see what's happening before you take a screenshot? Or are we fine with the scribbles? If you feel strongly that they need to go, just let me know. Otherwise, I'm going to leave them there for you guys to take a screenshot. Okay, and then guys, don't forget all of this is past papers. So if you feel you need to be practicing more circle geometry, please do, and like go look at past papers. You have, like, you get the memos with them online. There's no harm in going to look at them. And it just gives you more practice. Okay, so it's really important that you do go and look at past papers. Okay, so we've got 6 minutes, which is something else short. For those last 6 minutes, you are going to have a look at this first question, 8.1. And you're going to find for me these 3 angles, P, M1, and O1. We'll see if we can do the answers. Let's see what we get. If not, I will give the answers at the beginning of our lesson on Monday, so don't stress. So in the diagram, O is the center of the circle, MNPR is a cyclic quadrilateral, and SN is the diameter of the circle. Chord MS and OR are drawn. Angle M2 is equal to 64 degrees. So I want angle P. I'll even put little colors here for you. So angle P, apparently I won't, which is down here. Yeah, that is on it. Love it. Angle M1. And then angle O1. Right, remember your reasons. Okay, guys, hopefully what you can see is generally question 8 to like 19 are all your circle geometry or geometry questions, and those are generally the last questions of your paper. But hopefully what you're seeing just by having a look at this is now another new paper. They always start off with a nice easy question of just find some angles. Sometimes it's with numbers, sometimes it's in terms of X, but we generally start off with a nice easy question, just find the sizes of the angles, and then we get into things like prove it's a quad,